Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will cover Unit 12 of the course M256 Software Development with Java. Unit title is User Interface Design. In the previous unit, Human-Computer Interaction, Unit 11, we introduced you to the concept of human-computer interaction, the interfaces, types of interfaces, the importance of a human-computer interaction, principles of building a human-computer interaction and user interfaces, and we introduced you to some of the user interface components. Today, we'll have a look at the historical landmarks in user interface design. We will discuss the usability concept and the user-centered design and how we build our interfaces based on the user needs. We will discuss some of the heuristics and techniques of a heuristic evaluation when designing interfaces, and we will apply some of these heuristics evaluations to the design of a hospital system. First, having a look at the history of user interfaces. One of the main computer systems that contribute to the discipline of HCI is Sketchpad, implemented by Ivan Sutherland in 1962. It was the first highly interactive graphical user interface, first system to use Windows in some kind of Windows, and the first object-oriented system as the component were based on the idea of object orientation. Then the Xerox Star, which is a very, very important development in HCI history. The scientist Alan Kay and his research group created Smalltalk, which is a language or the first object-oriented programming language. The Xerox Star computer and its interface were the first major showcase for Smalltalk project. Although it was never commercially successful, it was the first commercial system to incorporate key HCI concepts in a systematic way. Macintosh and its chief executive Steve Jobs had a very important contribution for human-computer interaction and human-computer interface design. They refined the HCI ideas developed by Smalltalk and Xerox Star. These ideas were the foundation for Microsoft Windows later. They were based on object-oriented technology, as each component built was by itself an object of some interface class. Xerox Star and Macintosh, which was built on it, was based totally on what we call user-centered approach, which is an approach that focuses on the user when designing the interface. It's based on observing users, classifying them, understanding their needs, and building the interface based on that. They were based on making things easier to use for users, user find it easy to copy than to create, easy to deal with concrete entities than abstract entities. User find it easy to choose instead of filling in, and easy to edit instead of program. So these are the bases of how can we make the user's life easier. 0x*, user-centered approach. Implementing some very important ideas like consistent use of user's familiar mental model, seeing and pointing than remembering and typing. What you see in the screen is what you get on your printer. The use of universal command to mean the same thing for the user, and giving feedback. Let's have a look at these ideas. Making consistent use of the user's familiar mental model is very important. Some of them are the metaphors that we have discussed earlier. For example, instead of writing a command for copying or printing, we use a graphical representation. For example, a printer instead of writing a command to print, or a scissors instead of writing a command to cut. We also shown this idea before in chapter 11 or unit 11 when we use the metaphor or metaphors. We use the watch metaphor, the calculator metaphor, and so on. It's important that we don't force our user to remember. Instead, we show them things that need to use. And by this, we reduce mistakes caused by human memory and typing errors. Text formatting used to be very complicated and use strange commands to get simple text formatted the way that you want. 0x* pioneered formatting tools in which what the users see on the screen is what he will get on the printer. Using universal commands is very important. So when we say delete, edit, copy, whether I am deleting a picture or deleting a file, I use the same command, delete. Copying a text file or an image file or a movie file is copying. So it's a copy command, regardless the object I am dealing with. And this is the idea of polymorphism. We have discussed this concept before. Means the object will perform the same task in a way appropriate for its objects. Now, inheritance also is a very important concept that's applied to human-computer interaction. We have windows, for example. A window can be used to create new objects of type window, like for example dialog. Dialog is a type of window, so I don't need to reinvent dialog. I can always reuse the existing window object to create a dialog box object, and that can be applied on many other user interface components. We use the features from super class components to build new components. Going back to the basic concept of object-oriented programming, which is object, human-computer interaction is connected highly to object-oriented programming language. Graphical user interface components are basically objects. A button is an object, a window is an object, a menu is an object, an item in a menu is an object. So we are talking about very good example of implementing object-oriented paradigm in software engineering. Now, a very important term in software engineering is usability. Usability refers to how easy and quickly a product enables users to achieve their goals. If the interface is easy to use, if the interface is safe to use, if the interface is enjoyable to use, if it can help me doing my tasks as a user in a fast, easy, enjoyable, entertainment way, then I call it usable interface. Now, to be able to build such an interface, I need to give my user high attention. I need to put my user in the center of my understanding and analysis for my user interface. I need particularly to answer the following questions. Who are the users? What are the tasks that the users need to perform? What is the situation and the environment my user will be in? We start by answering the first question. Who are the users? This will include answering more questions, relevant questions. First is, will the user be expert or untrained in the business area of the system dealt with? So if he is expert, I will consider some aspects of the interface. If the people are untrained, then I will consider different aspects. Are they familiar with the computers, or they are new to the computers? Are they familiar with some particular operating systems? If they are very familiar with Windows operating system, then I may consider using some of Windows features in my design. If they are more familiar with other operating systems, I may have a look at those operating systems and consider using some of their features, so I can make it easier for my users to deal with the new system. Are they familiar with systems or any other related systems? Do they use the system occasionally, or they are regular users for the system? This is very important, because if they use it every day, then this is to be considered and taken in account. Do my users have any problem with sensor abilities? Do they have any physical disabilities? This should also be considered, and we mentioned in Unit 11 that we have what we call the extraordinary HCI. These human-computer interactions and human-computer interfaces built for people in need, in special need. Do I need to consider my user's age, their culture, their background? This is very important. When you have components from your culture in your interface, then you like the interface more. The way I build the interface for senior citizens is not the same as for children. People with higher education deal differently with interface from people with no education. This all should be taken in account. After considering the users themselves and their abilities and their culture, their ages, and so on, now we consider the task that we are performing. So what the user is trying to achieve is very important when we're designing our user interface. From where to get the information about the tasks, we go back to chapter 2 to the requirements document, where we have interviewing and observing the clients and the stakeholders, and we get the information from that particular document. The last question to answer is, what is the situation or the environment that will be around the system? Will it be a noisy environment? Is there good lighting in there? Is it wind? It's cold. Sorry, is it cold? Is it windy? Is it wet? Is it noisy? And so on. Do people wear special clothing when they use the system? They could be and need to wear gloves or glasses or any other thing that may not allow them to deal with the system the way that the normal people deal with because of their dressing or their clothing. I need to study all this, and if I don't have enough information in the requirements document, I need to collect more information about my user so I know what do they need, what's the environment, and what's the task they are performing. As we mentioned earlier, our ways to get this information is to have questionnaires, asking questions for our users to find more about their abilities, their tasks, and their situations. We may look at some good practices or documentation, and we may do some observations for our users. Simple questionnaire may give us an idea about all what we need about our user. Questions can be simple questions or open-ended questions. In case of open-ended questions, we ask question, and based on the answer of our user filling the questionnaire, we may ask more questions. As example, and for the case of a hospital system, we may ask questions about the following points. For example, in the hospital system, we ask how many patients are admitted each day. We may ask questions about different staff and shifts that they are working at. We may ask questions about how do they deal with missing information. Any problem that faces them when doing any of their everyday activities. Asking them about their opinion of how we improve different aspects of the system and the interface. All this can be in the questionnaire. We have many resources for the information from the available documentations. We can refer to job descriptions, related websites, public materials, annual reports, internal reports, and so on. This can be very useful because all this documentation will record the problems that people face, the issues that they are concerned about. Here is some example of what we may get from the documentation of a hospital system. It describes the users, describes the tasks, and describes some situations regarding this particular system. Observation is also very important method to collect data about our user. It gives us answer about many questions regarding the users, their task, and their situation. After collecting this information, we need to analyze it, and that will typically cover user characterization, means what are the characteristics of the user that might be related or relevant to designing the interface. Task analysis, which likely to refer to the use cases already detailed in the requirements documentation, because these are the tasks that need to be performed and the functions that the system needs to perform. And also situational analysis, which summarizes the environment in which the system will be working. As we mentioned earlier, user interface should be separated from the core system. They are distinct, but at the same time they are interdependent. And since they are distinct, then they can be developed in parallel. And one of the very important techniques that we have discussed and covered in Unit 1 is a prototype. And the prototype very much fits the development of user interface. You as a developer can build a prototype for the user, and that prototype will allow user to take a look and feel of what's going on in the interface. And by dealing with that prototype interface, they can give you a very good feedback about the interface, and you can, as a developer, use this feedback to improve your prototype of the interface and indeed improve the whole cycle of development and the development of the rest of the system. Now, how we are going to test our usability for our interface. One way is to get the feedback from the prototype user and improve that prototype and allow the user to give you more feedback about the new version and so on. So you continue with improving cycles until you get high satisfaction from the user. You also can test your interface by observing the user using the interface and recording what you find from that observation. This observation can be formal or informal, and the observer can be active or passive. And this observation can be direct or indirect. In the case of formal or informal observation, the difference between the two environments is that the formal observation makes or depends on some tight, controlled environment, where the informal observation allows users to do whatever they want to do in a very flexible way. Now, the observer can be active means involve with the interaction, or he can just be passive watching without being involved in using the interface. The observation can be direct, where the observer is watching the user using the system, or indirect by watching him through a camera or watching his interaction later using some recording of that interaction. Another very common way of testing the usability is what we call the think loud, which is simply a usability test technique that involves users speaking loud what they are thinking when using the interface. So if they are happy, they will say it. If they are confused, they will say it. If they find it hard or easy or enjoyable or less enjoyable or frustrating, they say it. So they speak out loudly what they think about the interface when dealing with it and when interacting with it. Usability has some measures, and these measures are how effective, how efficient is the interface, and how much the user is satisfied with the interface. So how effective is the interface, and the quality is called effectiveness, which means getting the right thing done. One possible way of measuring effectiveness is using some numerical terms, such as, for example, success rate or failure rates. Efficiency indicates how much of the resource has to be expended to get the job done. And basically, the time is the reference for this particular quality. If the task is done faster in shorter time, then we say that the user interface is efficient, as the user can do the job faster or perform the task faster with this interface. Now, user satisfaction is how happy the user about the system and whether they are enjoying using their system, happy about their efficiency and their effectiveness when using the system. SCI experts normally use a small number of pieces of relatively concrete advices that they call them design heuristics, or simply heuristics. This word is taken from the Greek to mean I find, and they are just advices that you may follow, you don't have to follow, to improve your interface. Now let us have a look at the design heuristics recommended when designing a user interface. First is use simple and minimal dialogue. Means trying to make your interface components and design as simple as you can, and minimize the dialogue between the user and the system. Try to group related items in the interface together. Use simple grouping and ordering. Don't use jargon of IT. Try to use the language that your user speaks. so they can understand what do you mean by the commands appearing on the interface. People have difficulties of memorizing information, so in your design, try to minimize the user's memory load. We commonly do mistakes, and if a mistake is done, give the user the chance to undo things that they do. So in case of doing it wrongly, they can undo it and redo it the correct way again. Be consistent means follow the same style and let the same command mean the same thing in different screens in your interface. Giving feedback is very important for the user, and this is one of the basic principles of building interfaces. In every window, you should have a clearly marked exit from that dialog or window or screen. Try not to be the reason for users making mistakes. Try to make things clear so users will not do mistakes and errors. When you are giving messages, error messages to the user, try to make these messages appropriate and very clear, and suggest some kind of constructive solution for these problems. These 10 rules are good to follow in many of the situations to improve your interface design. You can always evaluate your interface against the heuristics covered in the previous slides to find out how good is your interface compared to the and difference to the heuristic design given here. The following slide will show us example of an interface that has some problems by not following the heuristics covered earlier. For example, from the first look at this interface, you find that you don't have exit button in all windows. You find it only in the last window. Means if you want to exit from this interface, you have to go from one window to another until you reach the last window, and then you will be able to exit. For example, look at the booking and make booking buttons in the first and second screen. You find that although they are doing the same functionality, they are placed in different place in the screen. The first screen, it's placed on the lower right corner, when in the other one on the upper right corner. That's inconsistent. If you want it to be consistent, then you place buttons in the same part of the screen all the time. Here are some issues with the heuristics and possible solutions for these issues. Now we are talking about the design of the interface for the big entertainment system given in this slide. We have issues with including the clearly marked exit. We are having issues with speaking the user language, and we have issues with consistency, preventing errors, and other issues. You may read them and compare them to the design given in the previous slide. Now we are giving you what exactly the issue is and how to improve and solve this problem. Another example is given here. In this example, all the issues in the previous slides are covered, and if you look at the interface, you find the consistency in placing the buttons. You find that every window has a title, or every screen has a title. Every screen has an exit button. Sometimes you call it exit, sometimes back, sometimes return. It is a way for the user to go back to previous screens or to go out of the screens they are in. Further discussion for the design is implemented and given in these slides. Designing the hospital system interface is not an easy task. In these slides we'll go over what's required to be able to design a good user interface for our hospital system. Of course, we need to refer to the specification document given in chapters 1 and 2 and use them to build our interface. Here are some of the specifications necessary to be able to control the problem. The hospital system graphical user interface will be structured so that navigation between screens is very simple, and this is the best heuristic to make things simple. For each screen, you will sketch an initial prototype design and then one improved prototype, and that will not take prototyping process further than this. As we mentioned earlier, activities can be taken to collect more information about the interface. One possible design is to build tabbed screens for your interface, which means a tab will take you from one screen to another. Then you can take these screens one by one and apply the heuristic rules to build the interface. Now we are considering the use case one by one and applying their details to build the screens. So we assume that for every use case we will have one screen, and to be able to build the screen the right way, we need to study the use case very well and see how user is going to use the interface, what data is to be entered, what comes before and after this use case, and what's the contribution of this case to the overall task of the hospital system. So from the use case, we decide what are we going to include in the user interface or the screen for admit patient. We are going to use and record the patient's name, sex, and date of birth. We need to record that the patient is under the care of a given team. We also need to use that some consultant doctor is heading the team responsible for that patient. We need to record the patient in a ward. So we need to build a prototype for this design. Before building the prototype, we may build the initial widget table to know what and decide what components and what widgets to use to record all that data required in the use case. Here you find that the initial widget table having 3 columns: information, input and output, and the widget we are going to use. And if you take them item by item, you find that they are the data that we need to record for the hospital system use case admit patient. You find that the widgets have 2 categories: either they are input widget or output widget. For example, text field is input widget, where text area is output widget, and these are to be placed according to the heuristics covered earlier in some prototype for the screen for the admit patient screen. Here is the initial prototype. You find that we have a title for the screen, we have the text fields for title, first name, surname, date of birth, and so on, according to the table covered earlier. Of course, you may find that we don't have any exit button, so this should be fixed and improved, and that will be improved based on the feedback from the user. Now we need to go over the design and get the feedback from the user, test this feedback and evaluate the heuristics in that feedback against the heuristics and guidelines given earlier. You will find ourselves now improving the interface with adding more features and obviously adding the exit button at the bottom of the screen. Now, treat patient is another use case. We go through the same process of describing the use case taken from the specifications document. We decide about the widget table and initial widget table, information, input, output, and widgets. And we have the first prototype and initial prototype for the screen. This will be evaluated against the heuristics and possibly a new screen will be built, avoiding all the errors and the problems and issues in the first prototype. This is the new one, and obviously it's improved very much. The detail of improvement is given in the slides and the unit. You can please refer to them. This is better prototype, which is the second one, after evaluating the heuristics in our design. Now we are at the end of Unit 12, User Interface Design. In the coming unit, Unit 13, we will discuss in a short recording building user interfaces using all the components and the principles and heuristics learned in units 11 and 12. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.